In factoring these, you might recall from Algebra 1 that you have a special quadratic case here, and that you don't have an x term, which means the x term is a 0. And we know that this one's special because the first and the second terms are both squared terms. So this is x times x, and this is 9 times 9. Same thing here, this is x times x, and this is 5 times 5. So that tells me that if I'm wanting to come up with the two factors, I need to make sure that the numbers I choose for they get that middle term, which is the x term, I need to get a 0. Well, since 81 is a perfect square of 9 times 9, and I want to be negative 81, that tells me that one of the 9's will be positive, the other 9 will be negative. So I multiply 9 times x, I'm going to get a positive 9x here. And I multiply x times negative 9, I get a negative 9x here. Then 9 times the negative 9 gives me the negative 81. Because I have the same numbers, but different signs, when I add the x terms, I will get a 0. So that gives me x squared minus 81 is the final answer. So the two factors are x plus 9 and x minus 9. We call these conjugates. Or basically, they both have an x and a 9 in them, but one's addition, one's subtraction. And because of that, the middle term will always be 0. So if this is enough to complete the next 3 problems, you'll find them to be very similar. Stop the video at this time and go back and look at those 3 problems. If you're ready to continue, then I'll continue the discussion on the second problem. So again, we have an x times x again for the x squared. And 25 is that perfect square of 5 and 5. Because it's 25, it's negative. That means that one of the 5's should be positive while the other one should be negative. So if I multiply x times the x, I get my x squared. And if I multiply my 5 and my negative 5, I get the negative 25. That's the answer I'm seeing above. Take 5 times the x, here I'm going to get 5x. If I take 5 times negative 5, I get negative 5x here. Because one of them is a positive and the other one is a negative, when I add those x terms together, I'm going to get that 0 again, just like I did over here. So the two factors are x plus 5 and x minus 5. Again, this is another example of a conjugate. Now again, I'm looking for no x term. We have perfect squares in these terms. We have x times x here. This is 3 times 3. This is 1 times 1. So we should be able to break this down and similar to the previous 2 problems and get a 0 in the middle. So I have a 9x squared and a minus 1. So x times x is going to give me the x squared, and 3 times the 3 is going to give me the 9. To get the negative 1, that means one of the factors is going to be a positive 1, or the other one will be a negative 1. So if I take 1 times 3x, I'm going to get a 3x here. And if I take 3x times negative 1, I'll get a negative 3x here. So that when I add the x terms together, just like the previous 2 problems, I'm going to get a 0 because I have 3x and negative 3x. So the two factors are 3x plus 1 and 3x minus 1. So if you didn't get the last one, if you want to stop the video and see if you can factor that problem, then turn the video back on when you're ready. So again, no middle term. 16 is 4 times 4, x squared is x times x, and 49 is 7 times 7. So again, it should look like the previous problems. So for the x squared, I'm going to do x times x. And again, I want a 0 here, so I'm going to put use 4 x, or 4 and 4 for the 16. I could use 2 and 8, but if I do that, I will end up with these two answers being different because I'm not multiplying by the same number. And then for the 49, one's going to be positive, and one's going to be negative for the 49. So if I multiply the 7 times 4x, I'm going to get 28x. And if I multiply 4x times negative 7, then I'm going to get negative 28x. So 28x, take away 28x gives me the 0. So I end up with 16x squared minus 49. So two factors are 4x plus 7 and 4x minus 7. So there's not a lot of special cases for quadratics, but this is one of them. And because there's no middle term, and so the x squared term and the constant term are both squares, these are the answers we should expect to get in terms of factors are called conjugates, meaning that they're the same two factors, 4x and 4x, and 7 is 7, but one's under addition, one's under subtraction.